Hi, this deck of cards was compiled to facilitate working through scalar product and cross product standalone questions. The scalar or dot product of two vectors A and B can be constructed by taking the component of A in the direction of B and multiplying it times the magnitude of B, or it can be expressed as AB blank. So what's the third multiplier?
The dot product can be, or the scalar
cosine of
product can be one
theta.
of those really vague abstract concepts, but basically you're just multiplying two vectors. So vector A dot vector B would be the dot product of A times B, or it can be expressed as the magnitude of A dot or times the magnitude of B multiplied by the cosine theta between them. So let's say I had this A, B, so vector A, and this is vector B, and theta is the angle between them. Then the way that you get the dot product is obviously the magnitude of A, B cosine of theta, or it can be thought of the projection of A onto B, so the x component essentially of A in the direction of B, okay?
The magnitude of the vector product of A and B can be constructed by taking the product of the magnitudes of A and B multiplied by the blank of the angle between them. So what is the third multiplier? It's the sine.
The cross product is definitely one of those concepts that
The
seems
sine
a
of the
little
angle
abstract,
between them,
a
but
little
watch and
esoteric,
learn.
a little out there. But the way you would mathematically express the cross product is vector A cross. This literally gives the function its name, the fact that you have a x cross or multiplication sign. So A cross vector B. But what this means in terms of value is the magnitude of vector A times or cross the magnitude of vector B multiplied by the sine of theta, theta being the angle between them, also expressed in terms of the unit vector n. Okay, and I'll break down what n is in a little bit. So let's say you have vector A, like so, and then it's attached to vector B, and then you have theta between them. So let's say that theta equals 30 degrees or pi over 6 radians, and the value of A is 10, and the magnitude of B is also 10. So the mathematical expression for this portion would be 10 times 10 times the sine of 30 degrees, and the sine of 30 degrees is 0.5. So this portion would be 50. And then the unit vector is the expression of a third vector whose magnitude is 50, but orthogonal or perpendicular to both vector A and B. And the reason why I denoted it n is because traditionally you may know the unit vector I represents the x-plane on the Cartesian coordinate system, and the unit vector j is indicative of going in the y direction. And then k is, so I, like 1, has a value of 1. And j has a magnitude of 1 in the y direction. K, a magnitude of 1 in the z direction. The reason why we call this n is because these two vectors can be like oriented in any direction. So we don't want to isolate them to the x, y, or z plane. But just know once you're dealing with cross products, you're dealing with 3 dimensions, okay? So in order to determine which way n is pointing, you have to take your index finger, point it in the direction of the first vector, which is vector A. Take your middle and try to point it in the direction of the second, which is B, and it starts to get a little uncomfortable. So uncomfortable that you have to like, kind of flick your wrist. And when you flick your wrist, your thumb is pointing down, so that's the direction of N. It's orthogonal, but in a downward direction, okay? Orthogonal meaning like 90 degrees angle. Okay? So it's orthogonal to both. So this is a vector whose value is 50. Call it vector C. Okay?
A vector multiplied by a vector is representative of the vector product or the blank product and will produce a vector or scalar quantity. So fill in the blank. It's a cross product.
So on the flip side or front side of this card, it basically says that the cross product can be vector of a final vector or scalar. And you're probably wondering, like, how the heck can it be scalar when in the previous card you just showed me all this stuff where you have like an orthogonal vector perpendicular to both incident vectors A, B, or just the first 2 incident vectors. Well, if you have vector A cross vector B, and so we know that mathematically this means the magnitude of vector A cross or times the magnitude of vector B. Then we have this little buddy right here, the sine of theta, and that is, all this is the magnitude of times the unit vector n, okay, pointing in some orientation or direction, some 3rd dimension. But what if this entire thing had a magnitude of 0? And the way it has a magnitude of 0 is if this term, the sine of theta, equals 0. And the way the sine of theta will equal 0 is like, let's say this is vector A, and then it's overlapping vector B. Well, they're parallel. There's no angle between them. The angles came like that, like so, okay? So they're 0, and you can't have like some 3rd vector orthogonal to them because the magnitude of the vector is 0. So this is the way in which this expression can be a scalar quantity as well as a vector quantity. But it's scalar if the mathematical portion of it is 0. Okay?
Magnetic force is an example of the blank product. So magnetic force is an example of what product? That would be the cross product. So if you consider magnetic field, the current, because magnetic force is Q, V, so flowing current, times B, times the sine of theta, hence a cross product. If you consider QV the current, the incident vector, and magnetic field B the second vector, then the force is going to be the resultant or the cross product, orthogonal to both the current and magnetic field. Okay. What is the cosine of 60 degrees? This is just really good trig practice. What is it? So let's say you have vector A. It's 1/2. Like so. And vector B. And you have an angle between them of 60 degrees. Okay. And if we're told that their cosine is 1/2, (1 over 2). We also know that another way to interpret cosine is the adjacent side, abbreviated ADJ, over the hypotenuse, abbreviated HYP. So the magnitude of the adjacent side over the magnitude of the hypotenuse is going to give you 1/2. Okay, so let's say vector A has a magnitude of 10 and vector B has a magnitude of 5. This would be correct. This formation, if you imagine like, a right triangle formation, because 10 over 5 simplifies to 1/2. So this is the way you can think of the cosine of 60 degrees. So 1/2 is the answer. 30 degrees equals pi over what radians? Pi over blank radians. So what term makes this expression true? It's pi over 6. In order to make sense of this algebraic riddle, you would have to know the definition of pi in terms of radians. So pi equals, pi radians equals 180 degrees in a Cartesian coordinate plane system, okay? So it only makes sense that 180 degrees divided by 6 equals 30 degrees, or pi over 6 radians. Okay.